Welcome to solverfy.
Okay, we have 3 carbocations, which I will reproduce here. And the question is asking, are these in order of increasing stability, with least stable on the left or first and most stable on the right? Well, of the factors that are present that control carbocation stability, since we don't have any double bonds or conjugation, we're pretty much completely looking at substitution. Or you may call it substitution pattern, right? And that's where we discuss whether the primary which bears the positive charge, the carbon which bears the positive charge is primary, secondary, or tertiary. So if we classify the following molecules as primary, secondary, or tertiary, let's starting here, we would say this carbon is attached to 2 carbons, therefore it is secondary. This carbon is attached to 3 carbons, which makes it tertiary, and this carbocation, is attached to exactly 1 carbon, which means this is primary. And if you recall, the most stable substitution pattern is tertiary, or the more substituted, the more stable the carbocation is. So I'll say most stable. But the less stable, or the less substituted the carbon is, the least stable it is. So in the case of these 3 molecules, we can tell right away that the primary carbocation is the least stable, which then tells us that this cannot be true. It does not go from least to most stable. This is false. And if you wanted to look a little more further into it, you could see that tertiary is more stable than secondary, so that's not a problem. However, you could fix this picture by moving the primary all the way to the left, and then it would be true. But in terms of just the question itself, the answer is just